All right, in this video, I'm going to take some time to go over some, maybe all of the review questions. We'll see. Full disclosure, it's late at night on a Sunday and I'm getting tired. So here we go. Question one just asks us to simplify this, and it doesn't give us a target, so we're just going to try to make it better than it is. Probably lots of things we could try. I'm going to go with my first gut instinct, which is sines and cosines. So cotangent of x is going to be cosine x over sine of x times sine of x plus sine of x cosine of x times cosine of x. My cosines cancel, my sines cancel. Looks like I have cosine x plus sine of x. I don't see this getting any better than this. I suppose we could try something like turning cosine into, I don't know, like 1 over secant or something, but I really don't think that's going to take us anywhere. So let's go ahead and call this one simplified. Number 2, I'm looking at this, couple options. I could turn cosine squared into 1 minus sine squared or something like that, but I think easier thing to do is just to factor sine out and see where that takes us. So I have a sine of x in both terms, so let's factor that out. Leaves me with cosine squared x minus 1. And I, of course, know that sine squared plus cosine squared x equals 1. And so I think my best bet here is to make cosine squared x equal to 1 minus sine squared x. And then I'm going to substitute that in. So I have sine of x times, and then cosine squared becomes 1 minus sine squared minus 1. And the 1's cancel, so it looks like I get sine x times negative sine squared x, which is negative sine cubed x. That seems pretty simple. Simplified simple, at least. Be careful when you see this cosine squared minus 1. Some of you might be instinctively thinking, oh, that's sine squared. But make sure you really think it through, because that is not sine squared. All right, let's keep going. Number 3, another simplified question. I think probably we're going to turn this into sine of x, and then tangent is sine of x, cosine of x. So that's going to give me cosine of x plus sine squared x over cosine of x. I think I'm going to get a common denominator here. So I'm going to multiply by cosine x over cosine x, giving me cosine squared x over cosine x plus sine squared x over cosine x, which gives me, put them together, cosine squared x plus sine squared x over cosine of x, which is just 1 over cosine of x, which of course is our good friend, what, secant of x. All right, let's keep rolling. I'm going fast. You can obviously, watch it several times if you need to hear it slower. You can slow me down, but I'm sure I'll sound even sillier than I do now. All right, so now we're moving off of just simplifying. Now we actually know what the target is. So now I'm going to try to turn this into secant of theta. Wow, this is going to be pretty simple because the Pythagorean theorem tells me that there is one that says that tangent squared plus 1 is secant squared. So this says cosine of theta, and this just becomes secant squared theta. So what are we going to do with that? Cosine I could rewrite as 1 over secant of theta, which I wouldn't normally do, but I'm looking at my target. And so that times secant squared of theta, of course, becomes secant squared theta over secant of theta, which becomes secant of theta. Please remember, we need to not skip steps when you're showing a step-by-step pathway to the answer. All right. Another verify. All right. I'm thinking we need ourselves a common denominator. And, my gut tells me to turn everything into sines and cosines, but I kind of think that maybe I'm going to hold off on that. Maybe I'll regret it. Once again, just try something and move forward. I'm going to see this as I need to multiply. I'm going to show my step because I think you're going to want to see it. So I'm going to multiply this guy by secant x over secant x. So I get 1 plus cosecant of x over secant of x minus cotangent of x secant of x over secant x. So I get 1 plus cosecant x minus, ooh, this is kind of ugly, cotangent x secant x over secant x. All right. Well, I think I've avoided as long as I can. Looks like we're going to go to sine and cosine. How much room did I give myself? Not enough. All right. So let's move up here. So 1 plus cosecant is 1 over sine of x minus cotangent is cosine x over sine of x. Secant is 1 over cosine of x over secant. I'm going to go ahead and make that 1 over cosine of x. All right, on top, it looks like cosines cancel. So I get 1 plus 1 over sine of x minus 1 over sine of x over 1 over cosine of x. And this is working out really well. 1 over cosine of x, which of course equals cosine of x, which is what I was trying to show that it equals, and that turned out okay. For a different approach, you could check the answer key. I think I did this a different way on the answer key. It turned out this one wasn't so bad. All right, let's keep rolling. Verify. I think this one's pretty straightforward. I need a common denominator, so I'm just going to do that part in my head. So this is going to be a 1 minus sine x, the quantity squared, over cosine of x times 1 minus sine of x. So I just multiplied that guy by 1 minus sine over 1 minus sine. This guy gets a cosine, so he's going to get cosine squared x over a cosine x 1 minus sine of x. So just got a common denominator. Now I can combine them together, but I'm going to FOIL this out. This is a shortcut, or FOIL it out yourself by square the first term. The middle term is going to be multiply them together and double, so that becomes 2 sine of x plus sine squared x plus cosine squared x over cosine of x 1 minus sine of x. All right, sine squared plus cosine squared is 1. So 1 minus 2 sine of x plus 1. And that, of course, gives me 2 minus 2 sine x on top over cosine of x 1 minus sine of x. I'll move up here. Factor out a 2. 1 minus sine of x on top, cosine of x on the bottom, and 1 minus sine of x, which of course cancels out. I'm left with 2 over cosine of x, which is 2 secant of x, which is what I was trying to show. Nice and straightforward. All right, let's see what's next. All right, we're moving off of that. Now we're going to solve some equations. Find all solutions on the domain 0 to 2 pi. So once around the circle, 0 to 2 pi, how many different angles will satisfy this? All right, looking at this problem, it looks like I should factor a tangent of x out, giving me root 3 tangent x minus 1 equals 0. So we are factored. Set each factor equal to 0. And this over here would be tangent of x equals add 1 divide by root 3. So x equals arctan of 0. And x equals arctan of 1 over the square root of 3. I could rationalize it, but I don't need to because that's not my answer. So now I'm going to go take a look at a circle. Tangent, what angle is 0? Well, we know tangent, sine over cosine, so tangent's going to be 0 when sine is 0. So that's what I really need to figure out. When is sine 0? So sine is 0 at 0 and pi. Notice we're all the way up to, but not including 2 pi, so we're going to leave 2 pi off. And then arctangent of 1 over the square root of 3. So what I would do at this point is I would draw a triangle, and I would say, here is this angle we're talking about. And the tangent would be 1 and square root of 3. Oh, this is a 30, 60, 90. This is 60. This is pi over 6. Tangent's positive here. So I got an answer of pi over 6. And tangent's positive here. I've got 7 pi over 6. My answer would be x equals pi over 6 and 7 pi over 6. If you write them separate like I just did, please make sure you box them both. Make it easy to find. There you go. Those are my 4 angles that will work. All right, let's keep going. Let's try another one. All right, let's solve this one. I might think about turning secant squared into 1 plus tangent squared or something, but that doesn't help because I have a secant of x. So instead, what I'm noticing is that I can do some factoring, but don't factor the secant x out right now because it equals 2. Having factors equal anything but 0 is a waste of our time. We need them to equal 0. So this is actually a quadratic. This is secant squared x plus secant of x minus 2 equals 0. So do a substitution if you need to, but we're going to factor. And we're going to have a 2 and a 1. I need the 2 to be positive and the 1 to be negative in order to get a positive secant in the middle. Positive 1 in the middle. All right, secant x plus 2 equals 0, or secant of x minus 1 equals 0. So move the 2 over. I get the arc secant of, actually I'm going to back up because I'm unhappy with that. I'm going to write secant of x equals negative 2. I'm going to write the secant of x equals 1. All right, I don't like secant. I want to think about what? Cosine instead. So I'm going to simply basically do it in one step, but here's what I'm going to write. I know that secant of x is 1 over cosine of x equals negative 2. But I don't want 1 over cosine. I want cosine. So I'm just going to flip each side over, take the reciprocal of each side. And so that's simply going to give me the cosine of x equals negative 1/2. The reciprocal of 1 is 1. So I also have the cosine of x equals 1. So now I'm going to answer an arc cosine question instead of an arc secant question because I just don't feel comfortable with that. So arc cosine of negative 1/2 and the arc cosine of 1. Let's make a circle. Okay, cosine is negative 1/2. That means we're halfway over on x. Cosine's negative, so we're looking at these two angles. So that's pi over 3s. And so looks like we have the answer of x equals 2 pi over 3 and 4 pi over 3. And then when is cosine 1? Cosine is 1 when the x is positive 1. So that's going to happen only at 0. Those are my angles that will work. All right, next up, no more solving, but this time we're going to be solving for all solutions. In other words, not just looking at once around the circle. We're going to write a little formula for all the possible values. All right, what am I looking at here? Kind of a mess. I'm going to add tangent to both sides. So if I add tangent, that's going to be 2 tangents plus 1 tangent. So I have 3 tangent of x equals root 3. So I divide by 3. I get tangent of x equals root 3 over 3. Again, my brain actually thinks about tangent better if I can kind of unrationalize it. And I know that that's really just 1 over the square root of 3. So when I do x equals the arc tangent of, write either one down, but what I will be doing is I'll be now quickly thinking about a triangle. So here's x. My tangent's 1 over the square root of 3. This is 1, 2, 3. This is pi over 6 again. So making sure I didn't make a mistake, there's no square root that I took, so it's not positive and negative, so it's only positive. So when is tangent positive? Tangent is positive in quadrants 1 and 3. So we're looking at a pi over 6 angle here and a pi over 6 angle here. I should quickly recognize, well, number one, these are my only 2 answers once around the circle, and they're separated by pi. So I could say that the answer is pi over 6 plus pi n. Start at pi over 6 and then add pi over and over and over and over again for all values of n. Okay, that should do it. Next up, number 10. All right, first thing I'm noticing is that cosine of 2x. So I could possibly do some converting using my double angle formula, but I'm also noticing this is my only trig function mentioned. There's only one term with a trig function. So I actually am going to leave the 2x alone. So I'm going to solve for the cosine of 2x, which would equal root 2 over 2. I'm going to now take the arc cosine because I want to get rid of cosine. So I get 2x equals the arc cosine of root 2 over 2. I'm going to pause here. I'm not going to divide by 2. I'm going to figure out what the right side equals at this point. So we're looking at a circle. We should recognize that we're dealing with the world of pi over 4s. Cosine is positive. I did not take the square root, so it's not positive and negative. So we're looking at when cosine is positive. So we're looking at these 2 angles. So these are pi over 4s, negative and positive. And those are my only answers. So the easiest way to say this would be what? Positive or negative pi over 4. And then wrap around the circle again and again and again from each location. So either start at positive pi over 4, wrap around a bunch, start at negative pi over 4 and wrap around a bunch. Oh, but that's the answer to 2x. Now is when I solve for x. And so I divide by 2 and I get positive negative pi over 8. And divide by 2 and I get pi. That's how we deal with the cosine or the 2x angle. All right. Add 2, divide by 4. Sine squared x equals 2 over 4, or 1/2. I'm going to take the square root of both sides, and I get x, sine of x, equals positive and negative 1 over the square root of 2. And x equals the arc sine of 1 over the square root of 2. Rationalized or unrationalized, I should recognize this as a pi over 4. And I am looking at, I dropped my positive and negative, but again, I'm looking at positive and negative. So I'm looking at pi over 4 in all 4 quadrants. There's the easy ways, there's hard ways, but what we should recognize is that we are basically 90 degrees from each one of those. So I'm going to say x is, I'll start at, say, pi over 4, and then I just have to add pi over 2 over and over and over again. And that'll pick up all the other ones. That would be the most efficient way of giving the answer. All right. This next one, I have 2 different trig functions. I don't like that. So I'm going to convert. And this is where our work with identities and our work with solving equations mix together. So I'm going to turn cosine of x, actually nothing to that, but I'm going to turn cotangent into cosine of x over sine of x. All right, I still have 2 trig functions, which is not ideal. So let me just look this over and see if I'm overlooking something obvious. And I don't see anything. So I'm going to keep just messing with the left side. I'm going to get a common denominator. So I get 2 sine x cosine x over sine x minus cosine x over sine x. This is feeling a lot like our identity work. I can put those together now. The difference between what we're doing right here and our identity work is that we're not going to turn the left side into 0. So this is not a situation where for every x value, the answer is 0. At least I don't think. What we're going to find is there's a very specific one. So that's why it's not truly an identity, but we are still manipulating the left side just like we did with the identity work. All right, looking at this problem now, I could come to a pretty obvious, I hope, conclusion either now or in the next step. But if we're trying to take this fraction and make it equal to 0, we should know that only the numerator equaling 0 is how that would happen. You can't have a fraction equal 0 unless its numerator is 0. So in other words, this divided by sign, it's not doing anything, right? It is, we could throw it away. Another way to look at it is you could, I don't want sine down here, so you could multiply both sides by sine, and they disappear because it's times 0. However you want to think about it, at some point you should realize that the sine of x is not going to lead to any part of this answer. I'm going to leave it there for now, just because I'm a little premature, I think, in that conversation, because I'm still focusing on the top. I can factor out cosine. So I get cosine x times 2 sine of x minus 1. Again, I still have over sine of x, which would be an issue, except, like I said, we don't care. So at this point, I'm just going to drop it, and I'm going to answer the question, when is cosine of x equal to 0? And when is 2 sine of x minus 1 equal to 0? So x equals the arc cosine of 0, and then x equals, add 1, divide by 2, the arc sine of positive 1/2. We're going to go to our circle. Cosine is 0 when x is 0, which is going to be at pi over 2 and 3 pi over 2. And arc sine is 1/2 when we are here and here at pi over 6 and 5 pi over 6. All right, I don't see a great way of writing all 4 of these together because there's no common spacing, but I can do it in 2. So I'm going to say x is equal to pi over 2 plus pi n. And then I'm going to say x equals, I'm going to start at pi over 2, but I'm going to tell you to add and subtract pi over 3, because this is pi over 6, so this is pi over 3. So if I start at pi over 2 and add and subtract, that puts me at those 2 locations, and then let's wrap around the circle as many times as necessary. Okay. Let's keep rolling. All right. Looks like, I was almost about to ready to factor out a sine, but then I noticed it's 1 and not 0. So factoring sine out would be a waste of our time. So instead, I'm going to move the 1 over and make this a quadratic, which hopefully will factor. Or I guess hopefully it won't. I don't have to do anything. Do a substitution if you need to see it. But I'm going to have a 2 sine x and a sine x. I'm going to have a 1 times 1. And then if this works, 2 minus 1 is negative. Okay, so I need a negative 2 and a positive 1. And that should work. So 2 sine of x plus 1 equals 0. Or sine of x minus 1 equals 0. So x equals arc sine of 1. And let's see, subtract 1, divide by 2. X equals the arc sine of negative 1/2. Circle time. Arc sine of 1. Sine is going to be 1 when the y value is 1. So that's happening only here. Everywhere else is 0 or negative 1. The arc sine is negative 1/2. So that's pi over 6, but sine is negative. So we're looking at pi over 6 and pi over 6 here. And I recognize that this is going to be 2 pi over 3. This is 2 pi over 3, and that's 2 pi over 3. So everything is separated by 2 pi over 3. So I can say the answer is x equals, I need to start somewhere. I'll just start at pi over 2. And I'm going to add 2 pi over 3 n. And that should get it. All right, I'm probably going to end this video here pretty soon because it is getting late, and I got to go at work again soon. Let's do 14 and 15 and probably call it. So I'm going to add root 3 and divide by 2. So I've got cosine of 3x equals root 3 over 2. All right, I'm going to leave the 3x alone for now. I'm going to take the arc cosine to get 3x equals the arc cosine of root 3 over 2. All right, so I'm going to go to my circle, root 3 over 2. So that's going to be the cosine. That's the bigger one. So we're going to be looking at cosine is positive. So we're looking at these two angles. And these are pi over 6s. And so that means I'm going to say the answer is simply positive or negative pi over 6. And then add 2 pi n. 2 pi n times. N could be 0, n could be 1, n could be 2, n could be negatives. Either way, we would land on those locations. But now I divide by 3. So I get x equals positive or negative. That's a pi, not a 7. It's a very messy pi. That's going to be pi over 18 plus 2 pi over 3 n. If this was a problem that we were going to answer between 0 and 2 pi, if that was the question, then what I would need to realize is that my last step is to divide by that 3. So what that does is it takes angles that are way outside of 0 to 2 pi and brings them in. So if I was going to make a list, I would need to make a list 3 times more than what I thought I would need. So in other words, I would need 6 angles, wrap around the circle 3 times. So pi over 6 and 11 pi over 6, and then go around again, and then go around again. Those would all be outside of 2 pi, but when I divide by 3, they would come down into 2 pi. All right, hopefully that makes sense. Let's do 15 and call it a night. All right, not sure what's going to happen on this one, so let's just move the cotangent over and see what happens. So cotangent of x cosine squared of x minus 2 cotangent of x equals 0. There's a cotangent in both terms, so I'm going to see about factoring that out since it equals 0. So that gives me cosine squared x minus 2 equals 0. So cotangent of x has to equal 0, or cosine squared x minus 2 has to equal 0. All right. When I think about cotangent equaling 0, I know really what it comes down to is, again, the numerator equals 0, which is going to be cosine, right? Cotangent is cosine over sine. So really this just kind of turns out to be, I could really just dump the whole cotangent and think about cosine instead. So x equals arc cosine of 0 will get the question answered for me. Over here, I'm going to add 2 and then take the square root. So I get cosine of x equals positive or negative the square root of 2. So now I go to my circle and I think about when is cosine 0. Cosine 0 when the x is 0. So cotangent is 0 when cosine is 0. So it looks like we've got pi over 2, and we've got negative pi over 2 or 3 pi over 2. And then we're looking here, and this should start to seem a little bit ugly or weird because I don't have a known angle of root 2. I've got root 2 over 2, but that's not root 2. Then I start thinking about, wait a minute, what is root 2? Root 2 is a number that's bigger than 1, right? Because root 1 is 1, root 2 is bigger than 1. Cosine of x, there is no angle that'll give you an answer bigger than 1. So this has actually no solution to that part. It doesn't lead us to an answer. So our two answers are already found. So x equals, I would say pi over 2 plus pi n. Start at pi over 2, add pi, add pi, add pi, and there you go. All right. I may make a second video kind of finishing off this review, but hopefully what I have shown has been useful for those who need it. Let me know if you have questions in class.